This video we walk through solution for the worksheet 6. In this case, we for the reading and interpreting and engineering drawings, and the way we apply it is to determine the quantity for each of the item that we list here. For the reference, that is the worksheet 6 reference, and that is the project we are going to use. And the same wastewater treatment plant located in Madison, Wisconsin. And I suggest you to pull that out on canvas to when we walk through with this to show how to read and can get the quantity from that. So that one we need. And of course, on the right side, you see the template to put the quantity, to record your quantity with the length, the dimension, length, width, depth, or height, unit. For one item, what is the quantity? For the total, how many use repetition, symmetry, etc. And then we have the total for all of the item, and then the unit for that item. And the item that we need is first excavation volume, and we assume one slope. It means one horizontal and one vertical, so it means the slope is 45 degrees. And we also need 2 feet wider for each side of the base, so that we have workers walk around to do the tank. And then the volume of concrete for the tank bottom slab, I went over that a little bit in the previous video with the same project, but we will work into the detail, the number in a minute. And then the volume of concrete for the tangles and the pilaster, volume of concrete at the tank group slab and beams, volume of formwork required for the tangles and pilaster, formwork required for the tank group and beams, water stop use, and then rebar for the tank bottom slab and dowel for each base. So of course, if you want additional practice, we need to find all of this information. So here and in there, I also have from that template, you can fill out, for example, here excavation volume and what should be the dimension that take it from the drawings. And then of course, you Excel, they can be able to calculate for us with the formula we use. And with that, I pull out here and I walk through with you the information where I can get that information from drawings, so that you can be able to determine by yourself. So the excavation volume, and we assume one slope, 2 feet wider, and this is the information I got it from drawings and where that come from, and that go to the reference of this worksheet. So the go to the excavation volume for the tank, and that is the 78, the item, water treatment, pre-treatment tanks that we're talking about, and that is the drawing here. And you can see the length and the width 59.7, where that come from. So this is the tank. So you excavate, basically you put, this is the tank, you put out, so you need to find out the width and the length and apply the modified average and area method. Remember, L over 3 times A1 plus A2 plus square root of A1 times A2. That is the modified average and for prismoidal shape. But we need to find out what is the area at the bottom, what is the area at the top, what is the height of the depth of the excavation, so they can use that equation. And with that one, I need to find out the areas. Then we have to find out the two sides. So that, how can we find out? So from the drawing here, and that is the drawing number 78 SM1 with the plan view of the tank. So we can be able to find that down here. Find out. Okay, so let's make it smaller. Okay, here, so that one here. So you have the 78 57 for the width, 57.8, and the question need to have 2 feet in each side, so you can add that too. And then the excavation here, the other length 116 feet and 4 inches. So that what we have in this one for the each side we have 2 feet, so we add that in, and then 116 4, so you can add that in there to get the 2 dimension 118 here from 116. Put 2 feet for spacing for people to work on. The height of the depth, and I make a note in here where that the excavation, I say the existing elevation, we assume 32 feet. Why that? And how can I come up with the 14.5 feet? So it's 32 with the existing ground level, and then go down to here. If you go to this section B cut that we had in drawings SM3, then what we have, the elevation is 19, so go down with 19. What is the existing ground level? It's not 36 42. This is after the tank already complete, so you have to see the existing ground level. We need to go to the civil drawings, which is go up, and that one here. So that is, you go to 20 C9 and go to the contour map. For you study surveying, you know what I'm talking about. So this is contour map, and it shows the elevation. Of course, this is slope. You see that in contour, you see the elevation of existing 36 feet, 35, 34, 33, 32, and then this is almost flat, go down 31. So that is basically slope from here higher, go down this way. And of course, for that, we can make it approximate it somewhere in the middle. I assume that is 32 feet. So that about assumed level at the existing condition is 32 feet. So from that one, we can be able to find out the height of the depth based on the existing and the elevation here 19, and when to excavate further 1 foot and 6 inches. So that's why we have the equation here. You see 32 go down 19, but we don't go down further 1.5, so we get that elevation, and then we apply the modified average and area method, L over 3 A1 time A1 plus A2 plus square root of A1 A2. We get that. And how many quantity? Only one number, one tank. So we can find out that and divide by of course 27 to get the bank cubic yard, because that is the original condition for that. So that the way to find out excavation volume. The question next is to determine the volume concrete for the tank bottom slab. Tank bottom slab, we do exactly the same. We go to drawings for slab. For the bottom slab, we can see in cross section to find out what is the thickness. So you can see there in SM3, and the thickness, as I mentioned earlier, for the bottom 1 foot 6 inches. And then we can go to the plan view to see the for SM 1 or 2, you can see the width about 56, the length 116. So from that we can see is here for the bottom 116, the length, the width, and the thickness here basically 1 foot 6 inches. So, and one item for bottom slab, we can be able to find out with the equation times these three lengths, we can get the volume, and that is cubic yard. Tango and pilaster is a little bit complicated. So in this case, we have to divide east and west goal, south goal, north, middle. Let me go one item. So east and west goal, what is that about in here? So east and west, so we need to show way north side of this. So this, as you can see, the plan north and true north. So basically this is north, this is south, and this is west, and this is east and west. So it's symmetrical, so we can use one in here. And you see the thickness of that goal, we can look at here, and that equal to the thickness of the goal is 1 foot and 2 inches, and one length of the goal is from here to there, so it's 55. You see around 55 there. And then we need to know the height of the goal. To know the height of the goal for the east-west, we need to see the cross section A and look at drawing 78 SM3. 78 SM3, then we can see the height. This is 78 SM3, and that one we can see the height of the goal. So you see that one here, you see the east or west goal, and the height you can see that is 17.2. So you know the width about 55, the thickness of the goal is 1 foot 2 inches, and the height, so you can find out the volume. So that what we have in here is goal 55. You see 1 foot and 2 inches, it means that number, and the height from here you see that is 17 feet 2 inches, so that is number, and there are two go, that one here and the other side there. So that's why we have two number repeat, so we get 5 volume for each item and for 2 items. And do similarly, now your chop, I'm not going to go again, but you do similarly for the other goal, which is the south goal, the north goal, and the middle, south and north, middle. And then we have the same there, right? And pilaster, so and pilaster, and the middle pilaster. So the end pilaster is here. You go here. So that is end pilaster. So basically the reinforce the goal, and you have to see that. Go to the detail 78 SM4 detail 1, and then the middle goal pilaster. So it also reinforced for the middle goal, and that go to detail 2 and in drawings SM4. So we can do that here. Go to SM4, and detail 1 and 2 here, SM4, and we have that detail. So you see the goal, and then you just have this and pilaster beam width, whatever beam width we have, and then the additional thickness is 10 inches, and that the middle pilaster we have 6 plus 6. This is the goal in the middle, and then 6 plus 6 is 12, so 1 foot, half foot one side, 1 foot one side, and then the beam width. So what is beam width? It here they show you what the beam width of this is 2 feet and 6 inches. So that we can determine, and then the height, basically the height of the wall. So from that we can be able to determine the end pilaster. So that you can see that in the width, beam width 2 feet 6 inches, additional here 10, and then you have the height of the goal, same as the pilaster go through the goal of the tank. So you can be able to, and pilaster, how many of them? 4. Middle pilaster, how many of them? 2. Why is that? You go to the plan view, and SM1. So you have 1, 2, 3, 4. So 4 end pilaster. Middle pilaster 1, 2. So that's why we have 4 and 2 in here. Do the same, we can get that. And of course, for the concrete, for the roof slab, we do exactly the same, but apply for the roof, which is drawing SM78 SM2. The next item we want to do, so the formwork required for the tango and pilastra. So there we will go to the next video. I will show you how to determine the water stop, the rebar, and the formwork.